Hello students, let us start today physiology of excretion. We are going to discuss about physiology of excretion. Physiology of excretion. Physiology of excretion described in two steps. Number one, chemical process. Number one, chemical process. Number two, mechanical process. Mechanical process. Number two, mechanical process. Physiology of excretion is described in two steps: chemical process and mechanical process. In chemical process, we will discuss about chemical process. We will discuss about formation of urea. How does urea form? So chemical process first includes deamination. First includes deamination and ornithine cycle. Ornithine cycle or urea formation cycle. So let us discuss. Physiology of excretion includes two steps: chemical process and mechanical process. Chemical process includes deamination and ornithine cycle, or in ornithine cycle we can say urea formation. So we will discuss about amino acid. We know amino acids. Amino acid is final product of protein. Amino acid is final product of protein, and during deamination, ammonia and keto acid is formed. Ammonia and keto acid, these two are formed from amino acid during deamination. In mammals, nearly all ammonia is produced by deamination of amino acids, and glutamic acid is a type of amino acids. In mammal, nearly all ammonia produced from glutamic acid. Now from ammonia combined with urea. Ammonia combined with CO2 and form urea. Ammonia combined with CO2 and form urea in presence of arginase enzyme. And this process is called urea cycle or ornithine cycle. We can write NH3. This is ammonia combines with carbon dioxide in presence of arginase enzyme and form urea, H2N CO NH2 plus water. So this one is urea. This is urea. And here is arginase enzyme. And this whole reaction takes place in liver. So liver is called detoxifying organ. Liver is called detoxifying organ. Detoxifying organ. And we have already discussed that ammonia, this ammonia is 100,000 times more toxic than urea. So ammonia is a very toxic, highly toxic substance that is converted into less toxic substance that is in urea, and this reaction takes place in liver. This reaction takes place in liver. So liver is called detoxifying organ. In first step we have discussed about chemical process. Now in second steps we are going to discuss about mechanical process. Mechanical process, urine formation takes place. Urine formation takes place in three different steps. Urine formation takes place in three different steps. We can say includes, mechanical process includes urine formation. Urine formation. Mechanical process includes urine formation, and urine formation discussed in three different steps. First step is glomerular filtration. Glomerular filtration, or we can say ultrafiltration. Ultrafiltration, glomerular filtration or ultrafiltration. Second step is selective reabsorption. Selective reabsorption. And third step is tubular secretion. Tubular secretion. So these are the three steps included in urine formation. We see here blood enter into Bowman's capsule through afferent arteriole. This is called afferent arteriole, and blood leaves the glomerulus through efferent arteriole. So this is afferent arteriole and this is efferent arteriole. Now the diameter of afferent arteriole is more than diameter of efferent arteriole. So pressure is created very high, and that pressure is created in this glomerulus, tuft of capillaries, and that is known as glomerulus hydrostatic pressure. And this glomerular hydrostatic pressure is glomerular hydrostatic pressure. Glomerular hydrostatic pressure. We can write it GHP. Glomerular hydrostatic pressure is 70 mmHg. 70 mm of Hg. 70 mm of Hg. Now this 70 mm of Hg is pressure created due to less diameter of efferent arteriole. Here the afferent arteriole has greater diameter and it has less diameter, and glomerulus has fine capillaries. So here pressure is created that is known as hydrostatic pressure, that is glomerular hydrostatic pressure, that is equal to 70 mm Hg. Now this GHP, glomerular hydrostatic pressure, is opposed by two pressure. Here is one pressure, this pressure is called BCOP. BCOP भनेको blood colloidal osmotic pressure. Blood colloidal osmotic pressure. Blood colloidal osmotic pressure. Blood colloidal osmotic pressure. And this blood colloidal osmotic pressure is opposing in opposite direction. So this value is written as 30 mm of Hg. We can write 30 mm of Hg. And another opposing pressure is created by fluid present in capsular space. Here in this space, this capsular space consists filtrate, and that also oppose the hydrostatic pressure. This one is another opposing pressure. This is another opposing pressure, and this opposing pressure is known as capsular hydrostatic pressure. Capsular hydrostatic pressure. Capsular hydrostatic pressure. Capsular hydrostatic pressure. And we can write it CHP. Capsular hydrostatic pressure is minus 20 mm Sg. 20 mm of Sg. So we see here three different types of pressure. Glomerular hydrostatic pressure, that is GHP. Glomerular hydrostatic pressure, that is GHP. And this glomerular hydrostatic pressure is opposed by two pressure. That is the pressure known as blood colloidal osmotic pressure. This blood colloidal osmotic pressure is due to plasma protein present in blood. Plasma protein, there are generally three types of plasma protein we discussed: albumin, globulin, fibrinogen. Now let us discuss. We can see here is a filtrate, and this filtrate is known as glomerular filtrate. This filtrate is known as glomerular filtrate. The filtered liquid is known as glomerular filtrate because it is filtered through the glomerulus. So it is called glomerular filtrate. And this glomerular filtrate contains substance which molecule is smaller than molecules smaller than 3 nanometer. Molecule smaller than 3 nanometer. Smaller than 3 nanometer, whose molecules smaller than 3 nanometer. So we can say the substance which can filter out through glomerulus, whose molecules are smaller than 3 nanometer. So this is the filtrate, and this filtrate is called glomerular filtrate. And this glomerular filtrate consists glucose, water, amino acid, salts, or we can say mineral, vitamins, hormones, urea, and creatinine. So these are the substances present in glomerular filtrate. These are the substances present in glomerular filtrate. Here glomerular filtrate rate, GFR, we can say GFR. R means rate. Glomerular filtrate rate is 125 ml per minute. This much 125 ml glomerular filtrate. This filtrate is 125 ml formed per minute. So in normal adult, in 24 hours, in normal adult, in 24 hours, 180 liters glomerular filtrate are formed by both kidney. In normal adult, in 24 hours, 180 liters glomerular filtrate is formed by both kidney. Glomerular filtrate is 125 ml per minute, or you can multiply 125 ml with 60, means in 1 hour, and multiply it with 24. So you will get this value, 180 liter. Now let us discuss about filtration fraction. Filtration fraction, or we can use the term FF. filtration fraction is equal to, is the ratio of glomerular filtration rate, glomerular filtration rate and renal plasma flow, RPF. So upper one, GFR is glomerular filtration rate. We have I have already written here glomerular filtration rate. But RPF means renal plasma flow. Renal plasma flow. Renal plasma flow. That is RPF. And this ratio is known as filtration fraction or FF. So you can write FF is the ratio of GFR and RPF. Or GFR we can put the value, we have already mentioned 125 ml per minute. And in blood, in both the kidney, about 700 ml plasma flow. 700 plasma flow. Or in total blood, in the case of blood, 700 plasma that is present in about 1300 blood. So I think you might have understood what is what is I am explaining. We can write it here. 125 ml is produced, that is glomerular filtration rate, and we have written it 700 ml. 700 ml is the amount of plasma, means 700 ml plasma present in 1300 ml blood. 1300 ml blood means you can say 1300 ml blood is filtered through the kidney, through both kidney, and this 1300 ml blood consists 700 plasma, because we know the plasma and blood corpuscles. So plasma is 700 ml. So the value, we can conclude this value. This value is about 0.17. So filtration fraction is, the value of filtration fraction is, we can write the value of filtration fraction is about 0.17. 0.17, this is the value of filtration fraction. Now see here, this is selective reabsorption. Selective reabsorption. There are two types of selective reabsorption. Selective reabsorption takes place in two different ways. That is active reabsorption and another one is passive reabsorption. Active reabsorption takes place against concentration gradient. It takes place against concentration gradient. But passive reabsorption or passive transport takes place by the process of osmosis. By the process of osmosis. No energy is required for passive reabsorption, but energy is required for active reabsorption, because it takes place against the concentration gradient. Now we can see here the structure. This is Bowman's capsule. This is Bowman's capsule. We see here, this is Bowman's capsule, and blood enter. This is Bowman's capsule. Blood enter through efferent arteriole. This is efferent arteriole, and take out from efferent arteriole. And here we can see a tuft of capillaries. Here we can see tuft of capillaries, glomerulus. We can see here tuft of capillaries, that is glomerulus. And around this structure, renal tubules, around this structure, renal tubules, from here, efferent arterioles, capillaries are surrounding this renal arteriole. These capillaries are surrounding, coiling around renal artery, and it is called peritubular capillaries. Peritubular capillaries. It is called peritubular capillaries. Peritubular capillaries. So this peritubular capillary is surrounding around these renal tubules. It is surrounding around PCT, loop of Henle, and DCT. So it is called peritubular capillaries. And we have already studied that, we have already discussed that here per minute 125 ml blood is 125 ml filtrate is formed here. Here it is formed 125 ml per minute. We have already studied. So this filtrate is 125 ml. Among these filtrate, the substances from this renal tubule is reabsorbed in peritubular capillaries. Now you will ask, what are the substances and in how much amount these substances are reabsorbed from renal tubular to peritubular capillaries. So we can see here glucose almost 100% is reabsorbed, amino acid almost all, vitamins almost all, hormones almost all, and minerals. Sodium ion is 75% sodium ion reabsorbed, potassium ion 75% reabsorbed, calcium, very large amount of calcium ion is reabsorbed by peritubular capillaries from this renal tubule. It takes place in active reabsorption process, or we can say active transport process. Now let us discuss about passive reabsorption. So passive reabsorption takes place by the process of osmosis. No energy is required. Here chloride ion 75% is reabsorbed, water 80% is reabsorbed, and urea 50% urea is reabsorbed. So this process is called selective reabsorption. In selective reabsorption per minute 1 to 4 ml filtrate is reabsorbed per minute. ध्यान दिएर सुन्ने है. Out of 125 ml filtrate, 124 ml filtrate is reabsorbed. That is reabsorbed, where I have told it about. This is reabsorption. This is called what? Reabsorption. So how much filtrate is found per minute? So you can find the difference, 125 ml minus 124 ml, that is equal to 1 ml. So per minute only 1 ml urine is produced. Per minute 1 ml urine is produced. Means in 1 minute 1 ml urine is produced, then in 1 hour 60 ml urine is produced, and in 24 hour about 125 to 2 liters urine is formed in 24 hours. Generally in normal human adult, the amount of urine is formed. is 1.5 to 2.0 liters urine is formed. So this is called a selective reabsorption. Now we see selective reabsorption. Further steps. From here we have already, this one is afferent arteriole, and here is glomerulus inside woman's capsule. So here filtrate is formed. The filtrate is called glomerular filtrate or ultra filtrate. Now this filtrate consists water and different substances whose molecular size is less than 3 nanometer. They are water, amino acids, vitamin, hormones, uric acid, and urea. And these substances are reabsorbed from PCT. This structure is PCT. From PCT, and it moves to peritubular capillary. So this one is peritubular capillaries. You can see here, this one is peritubular capillaries. Capillaries around renal tubules are called peritubular capillaries. So here in PCT, about 80% water and almost all amino acids, vitamins, hormone, uric acid, and 50% urea is reabsorbed. And from this descending limb of loop of Henle, this is descending limb of loop of Henle. This from descending limb of loop of Henle, about 5% water is reabsorbed by peritubular capillaries. This is called peritubular capillaries. And the filtrate moves through the loop of Henle. This structure is called loop of Henle. And this one is ascending limb of loop of Henle. And we know ascending this part is almost impermeable to water. This half part is almost impermeable to water. We know this is impermeable to water. Impermeable to water. We have already read impermeable to water and permeable to salt. But this region is permeable to water. This region is permeable to water and impermeable to salt. We have already discussed. So what from this ascending limb of loop of Henle, sodium ion, potassium ion, chloride ion are reabsorbed. Again, we can see here this structure is DCT. This structure is called DCT, distal convoluted tubule. From this distal convoluted tubule, sodium ion, chloride ion, bicarbonate ion, water are reabsorbed. But reabsorption of water depends upon the presence or absence of ADH. We know ADH. ADH is the hormone, antidiuretic hormone. So this antidiuretic hormone, presence of antidiuretic hormones in the blood make this half part, ascending limb and ascending limb, DCT, and this renal, this collecting duct. Permeability of water depends upon the presence or absence of ADH. If ADH is present, urine is concentrated, means less amount of urine is formed. If ADH is present, less amount urine is produced. If ADH is absent, more amount of urine is released. Means if ADH is present, then there will be absorption of water. About 19% water is reabsorbed if ADH is present. If ADH is absent, then the urine will be, then large amount of urine will be formed. What do you mean by the term diuresis? Diuresis means problem of formation of large amount of urine, or formation of a big volume of urine. That is known as diuresis. And here it is written antidiuretic hormone. So if antidiuretic hormone is present, then 19% of water is reabsorbed from PCT and less amount of urine is formed. If ADH is absent, then what condition will take place? That is known as diuresis. Diuresis means big volume of urine is formed, or that is known as problem of increased urination. You can say it problem of increased urination. Problem of increased urination. Another one is diabetes insipidus. We have already we know that diabetes mellitus and diabetes insipidus. In diabetes mellitus, glucose is present in the urine, but in the case of diabetes insipidus, it is only big volume of urine is formed. It is pathological condition. It is a pathological pathological condition in which big amount of urine is formed. Big amount of urine is formed, and this condition, this pathological condition, is known as diabetes insipidus. Diabetes insipidus. Let us discuss about tubular secretion. In tubular secretion, what will happen? This is peritubular capillaries. We have already discussed. This is peritubular capillaries. Peritubular capillaries means capillaries present around renal tubule is called peritubular capillaries. So from these peritubular capillaries, these substances are secreted, and these substances, uric acid, potassium ion, hydrogen ion, ammonia, creatinine, and para-amine hypuric acid. We can say it para-amine hypuric acid. Hypuric acid is secreted from these peritubular capillaries and discharge into renal tubule. And this is known as tubular secretion. So this is all about physiology of excretion.